Hey everybody, so today we're going to finish up our notes on the unit circle. So we are actually going to be on the back side of the original 5.7 notes that we started in class before. So if you have this paper, that's great. If not, we have some extra copies that you are more than welcome to fill in the back side. And then we will post the front and back completed both in Canvas. So recap from last week, we had our special right triangles. We were solving for our reference angles, and then based off of the reference angle we were given, we would use that value for our special right triangle. So the unit circle is a very specific example of our special right triangles because it's going to be a radius of 1 every time. So whenever we are dealing with the unit circle, we actually have a known value. No matter what angle or where we are, the R value is always going to be exactly 1. So because the radius is 1 for each point on the circle, if you had something like, let's say for instance, before we had sine being y over r, well, instead of y over r, we know that r is equal to 1. Well, y over 1 is anything divided by itself is just y. So what we're going to see here is anywhere that there's an r, it's going to go away, and it's going to be replaced by just 1. So for example, sine on the unit circle is just the y value. Cosine, instead of x over r, it's just the x value. And then tangent is unchanged. It's still y over x. For the bottom, it's just everything upside down. So instead of y on top, it's 1 over y, 1 over x, and then x over y. The second piece to note here is that xy coordinates, because cosine is equal to x and because sine is equal to y, we can now write our ordered pair instead of x comma y. We can actually change it to be cosine comma sine. And the last piece of information is that when we're dealing with these things on the unit circle, on the previous page, we had our triangles where they had a radius of root 2 and 2. So we actually have some new triangles that we can draw in that will help us. So for our 30, 60, 90 triangle, across from 3, it's no longer 1, it's 1 over 2. Across from root 3, or across from 60 is not root 3 anymore, it's root 3 over 2. And then our radius now is 1. So when we go over to our 45-degree triangle when we're on the unit circle, the same thing applies, is we are now looking at a radius of 1, so that's our R value. And then now we're going to have root 2 over 2 and root 2 over 2 as our two side lengths. So if you ever see that with your 45-degree triangle. So these are new. So this is new for today. So what we're going to see is when we have our special right triangles, when we find those reference angles, when we deal with the unit circle specifically, these are going to give us our x and our y values. So the unit circle is off to the right over here. It's not fully filled in, so we'll be able to kind of develop that as we go. But it's frequently used to map angles 30, 60, and 45, and their multiples, and it can also map angles on the axis. And the angles on the axis are, these are the quadrantal angles. So those are, for example, 90, 180, 270, and so on. So here is the unit circle off to the side. Going to show us with all of our reference angles. So here, making a right triangle, we would have 30 degrees. The next one would be 45, 60, and so on. So that is the work that we were dealing with on the front side. Now the difference is all of these line segments here are exactly equal to 1. And that's going to be what allows us to solve when we finish these questions. So there's only so many values you can get. So as you discover these values, it helps. You can always reference it because it'll always be the same thing when we are on the unit circle. So we're going to try to fill in a couple of these different types of examples, and you can see how these work when we are specifically on the unit circle. So 135 That's going to be in quadrant 2. So just a little bit less than 180. So 135 is here. 180 is here. So we want to take the difference, and that'll give us our reference angle. So reference angle here is 45. So we can go ahead and make this triangle larger. At 45, 45, 90. And then we have to remember that our new triangle with 45 is up top here. So this is the triangle that we're going to reference right here, our new special right triangle with 45-degree sides. So we're going to have across from 45 is root 2 over 2. Next to 45 is root 2 over 2. And because it's the unit circle, you're always going to see a radius of 1. And that's how you know that you are specifically on the unit circle. The second thing to note is this triangle is on the coordinate plane. So the coordinate axis is still there, so you still have x comma y. So that still exists. And we have to remember that our y value goes up. And in this case, from the center, our x value goes to the left. So it's going to be a negative x value. Now the last piece to reference is we go back to our original question, our new definition. And sine is just equal to our y value. So going back to this question, we've identified what our y value is, and that's going to be our final answer. So sine of 135 is equal to the root 2 over 2. And that is our unit circle reference. So if we go back to the unit circle now at 135 degrees, we can determine that this point right here, if we're going to list an ordered pair for it, we have an x value of negative root 2 over 2. We have a y value of root 2 over 2. And as we go through these questions, we're going to be able to start filling in our unit circle a little bit more as we go. So we have one value down, so let's go to our next value, 180. So for 180, I'm going to go to our axis, and we're going to see that this is a quadrantal angle. So we are directly down on our axis. Now the important thing to note, this is still on the unit circle, so our r is still equal to 1. And we're going to be at this point right here. So from the center to the edge here, that arrow making its way out there, that is 1. It is 1 to the left. We're going to say x is negative 1 because we've gone 1 to the left. And we haven't gone up or down, so we have y is 0. So our ordered pair here is negative 1 comma 0. And that's all that the information we have because it's directly on the axis. So if it's asking us for secant, well, the secant of 180 is equal to 1 over x, and in this case, x is equal to negative 1. That's where that came from. So because of that, the secant of 180 is a final answer of negative 1. So we can go back up to our unit circle now and fill that in at 180. Our ordered pair is negative 1 comma 0. So now if we have a future question that asks us about 180, we'll have our x and y values already done. All right, so we've done a couple examples with degrees, so let's jump down and do a couple examples with radians. So my advice, 3 pi over 4, we can convert that over. And the nice thing is we don't even have to do the conversion. We can look at the unit circle. We see 3 pi over 4 is right here. So there's 3 pi over 4. We know that that's exactly equal to 135 degrees. So 3 pi over 4 is equal to 135 degrees. In the first question we solved, we have x and y for 3 pi over 4. So because of that, we can use those same x and y values because we've already solved for 3 pi over 4. So to be specific, we've solved for our x value. We've solved for our y value. And always our r value is equal to 1. So cosine, in this case, cosine is equal to x. And x right here is the negative root 2 over 2. And that is our final answer. So the nice thing is once you've filled in your unit circle, once you've done enough questions to have the xy ordered pairs for enough angle measures, That's as simple as just looking at the unit circle, seeing what x and y are, and you'll be good to go. So if you have that done before your quiz, if you take enough time or you do enough example questions to fill in your x and y values for each of these ordered pairs as you go across, you'll have a completed unit circle. You can also use the internet. There are many completed unit circles on the internet. But the best way to do it, the first time at least, and you'll have to show work for it on the quiz, is how are we actually finding these references on the unit circle? How are we filling all of these things in? So we have a couple of them filled in, but we got to keep going. So the next one, we can take a look at 2 pi over 3. So what happens when it's not perfectly working? Well, we can convert it to degrees. So that's one method that we can use, but we can also look at the unit circle. So 2 pi over 3 on the unit circle is right here, and 2 pi over 3 is equal to 120 degrees. So now we have all of our conversion factors done for us, which is pretty nice. We don't have to do that work anymore. So 2 pi over 3 is 120 degrees. So we can draw out 120 degrees. It's right over here. That's 120. 180 is over here. So the difference between 120 and 180 is 60. So our full triangle, draw it nice and big here, has 60 here, 30 here, and 90 here. We have a radius of 1 as always. We scroll back up to the top to our new one. So across from 60 is the root 3 over 2. So we're going to go down. Across from 60 is the root 3 over 2. Across from 30 is 1 over 2. And we're going to see we are on the left side. So y is going up, going in this direction up. But from the axis, x goes to the left. So it's going to be negative 1 over 2. And r, as always, is equal to 1. So tangent is y over x. So our y value is the square root of 3 over 2. Our x value is negative 1 over 2. And we end up in a situation where we have a fraction on top divided by a fraction on the bottom. So our final step here is to do KCF. So keep the top, change it to multiplication, and flip the bottom. So root 3 over 2 multiplied by negative 2 over 1. So the nice thing is we have a 2 on the top and a 2 on the bottom. So 2 divided by 2 simplifies to just 1. So we are left with negative root 3. And that is divided by 1 on the bottom, but dividing by 1 doesn't make a change. It keeps it as negative root 3. So that is our full final answer for our question here. So the second thing that we can do is go back up to 120 degrees, and we've defined x and y for 120 degrees. So x is negative 1/2, and y is root 3 over 2. And we're one step closer to filling in our unit circle. So please complete the remaining practice questions here. These will be good practice for you. We'll post some references and answers in Canvas as well where you can check. So thanks for your hard work, everybody. Keep going with the practice, fill in your unit circle, and you'll be ready for tomorrow's quiz.